at number 37. So 37, we have our mean of 21 days that the chicken stays in the egg. Standard deviation of 1 day. So what's the probability random select for less chicken egg hatches in less than 20 days? Now something that is convenient here about this particular problem is that when I go ahead and attempt to draw on the graph, I realize, oh, 20 is one of the actual marks on my graph. 20 corresponds to what z-score? Well, there's 0, that's -1. So I actually don't really need to go through the whole process of doing the z-score calculation. I know this is going to be less than -1.00. Now, if you did the calculation, that's not wrong, certainly, but it just, saves a little bit of time. And when you do that, you should find 0.1587. Any questions about B, what is the probability that it hatches in over 22 days? So that, of course, would be more than 22 days. So that would be there, and oh, hey, look, that's another number on the graph. That's 0, so that's +1. So now I'm just looking up z greater than +1. Which, of course, would mean I'd need to do a complement to +1, but hey, guess what? It's symmetric. So whatever's to the left of -1 is going to be the same thing that's to the right of +1. So we get the same answer. Yes.
I only use the one LSA.
You do. You could just do 1 minus that because it's to the right. Other questions? All right, so then we go to C. What is the probability of random selected egg hatched between 19 and 21 days? Oh, but conveniently, again, 19 and 21 are both values that are on the graph. -19 is at 0, -1, -2. And 21, of course, hey, that's me. So that's 0. So I'll need to look up my value for 0, which of course it was halfway across, so 0 has 50% of the area. And then we need to subtract off whatever -2 is equal to. So if I look up -2.00, 0.0228. And so you should end up, after doing all of that subtraction, with 0.4772. Questions? On the way, there are being used for subtractions. Last question. Would it be unusual for an egg to hatch in less than 18 days? Well, we have that similar situation that we did earlier where 18 less might be extremely small. So that is definitely an unusual situation. Questions? Yes. Any other questions on our chickens? Now we're going to direct our attention over to 39. We're going to just do a couple of these problems because there's a couple of interesting things that are happening there. So in number 39, please take a few moments, just try B and C. On the table again. Yes, we need new graph papers on the table. So try 39, B, and C. It's about cookies. Questions about 39B? Yep, like 0, 1, 2.
Why didn't you do the compliment?
Didn't say more than, did it? Wait, fewer than 1,000 chips.
Oh, wait.
I was doing A. Wow.
No, but that was all.
No. B says, as we've seen, what is the probability? C says, what proportion? Does that change our process? Not at all. Remember that probability is another way to be interpreted as proportion. Okay? So you can use either of those things to make those sorts of questions or calculations. So what proportion of bags contain more than 1,200 chips? So even though it asks for a proportion, I'm going to do the same thing. So 1,200, I don't know, be maybe in there. And so of course we got to find their z-score. So it looks like we get a z-score of negative 0.53. Of course, we want to be greater than that, so we'll need to do our complement. So negative 0.53 looks like 0.2981. So that will be 0.7019. So if they ask for probability, they ask proportion, same process, same thing, no change in what we need to do. Now let's jump down, take a look at Part E. Part E says something different again. What is different about it? Percentile rank. Now, we know, of course, commonly that we can change probability into percents, or decimals or percents, they're the same thing. You know, just have to move the decimal place a little bit. Percentile ranks obviously deal with percents. So we're going to use basically the same process, but there's a little tweaking we have to do. So the first thing that you need to remember, you may want to jot this down somewhere, is that if you're being asked a question about a percentile, that means it's always going to be a less problem. Okay, percentiles, of course, refer to the percent of people or the number of people that are less than that particular value. So percentiles are always going to be less problems. And then, of course, when you talk about percentiles, you don't generally talk about percentiles as being decimal things. Normally, you just talk about the 50th percentile, the 63rd percentile, the 70th percentile. We don't use decimals, so we're going to have to round a little bit at the end. So if we look at 39E, this is what is the percentile rank of 1,475 chips. So I'll basically follow the same process until we get towards the end. So 1,475 will be somewhere in there. Oop, I said it's always less, and there I'm color right. And so then, of course, I need to get the z-score. So we look up 1.81. And we get 0.9649. Now, because they want percentile rank, they don't want probability or proportion, we are going to have to round this so that it looks like a percentile. Of course, you want to look to the third decimal and see if it's going to change your second decimal, because, of course, when you're trying to figure out a percent, you move it 2 to the right. So we'll 4 round the 9 to the 6 up. So then we will simply say as our final answer that we have the 96th percentile. So when it's asking for a probability or proportion, it's fine to keep those 4 decimal places. Those are your answers. Bam, done. It's happy. But if they do ask for the percentile, we need to do that little bit of rounding so that we are answering the problem appropriately. Questions? Megan? No, say that.